Welcome and hello. This is a lesson in the HEC RAS controller. We're going to be talking about reading input files. This is just an introduction lesson to the topic. HEC RAS input files are stored in ASCII text files, which means you can open them up in a text editor and you can read them. This allows the VBA programming language the ability to open and edit these input files. So what you see on the screen here is my HEC-RAS model. It's a very simple 1D model with one river reach, and then we have a couple cross sections, and then within each of those cross sections we have 8 data points representing the station elevation values. This model also has a flow file, a steady flow file associated with it, and a plan file. We're going to go ahead and open up the project directory, and boom, here it is. At the top, I've got a couple Excel files, so those are just sort of extra, not part of the HEC-RAS model. But then highlighted here, I have my .rj file, that's the project file, as well as a number of other input text files that are used for running the HEC-RAS model, such as the .f01 file, that's the steady flow file. We have the .p01 file, that's the plan file. .g01 is the geometric file. And you may also have additional files as well, but this is sort of the minimum for running a steady flow simulation. An unsteady flow file would have a .u01 or number as its file extension, but this project.f01 is the steady flow file. All right, let's go ahead and open up this geometry file. I'm going to pick on this file for this lesson as an example, but we can look at other input files that sort of work the same. I'm going to come down here to edit with Notepad++. You can also open it up in other text editors and IDEs, but I just have a preference for Notepad++, and boom, here is that geometry file. So let's go ahead and take a look at this geometry file. And ultimately, at the end of this lesson, what we're going to be doing is write a quick script in VBA to open up this geometric data file and then extract the specific data that we want. All right, at the very top, we have the title of this geometry, which is called base. And I'm going to flip back and forth between HEC-RAS and this file. So right here, the geometry is called base. This is the specific file path, at least until I rename it. So that's what it is right now. Okay, back to our geometry file. Next, it's running on version 6.6, and then the viewing extents is -1 to 2 in both directions. After that, we have the river reach defined, which is river A, reach 1, and it's separated by a comma right here. There's actually 10 points right here that are defining the coordinates of that river reach on the map. So here is the geometric data editor. Here is the cross-section editor. I'm going to close that here. If I go up to edit and then move points or objects, you can see that the little dots right here associated with each vertex point sort of stands out. So there should be 10 of these points: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So those 10 points are the 10 different coordinates that we're seeing right here. That doesn't mean the river is only 1 foot long or 2 foot long. Those distances are defined based on the cross sections. This is a 1D model after all, not a 2D model. So here is one coordinate, and then here is a second coordinate, and then there's 5 times 2. So that makes up the 10 different XY positions of the vertex points of our river reach. Also in the geometry file, of course, I pointed out we have 2 cross sections. So after the river reach is defined, we have a cross section right here, and then we have another cross section that's defined right here. So a cross section is a node, and on that river reach, the node is identified by this string right here. We have type rm length LCHR equals. So this right here on the left side of an equal sign is considered a key, and then to the right side of the equal sign is considered a value. So what we're going to be doing with the VBA code is to search through this file, searching for specific keys, whether it's type rm length LCHR, or maybe it's station elevation, or Manning's number, or range station. Because this is an ASCII file, it makes it pretty easy for us as programmers and developers to just parse through this file one line at a time, searching for keys, and then ultimately retrieving that data. So the node number 1 right here, this is the node type index. 1 represents a cross section, but you could also be, if it's a 2, that would be a culvert, 3 is a bridge, 4 is multiple openings, 5 is an inline structure, and then a 6 right here would be for a lateral structure. And then after that, we have a river station number, and then the downstream distance for left overbank, main channel, and right overbank. Depending on the node type index, you may or may not have other parameters here, but for cross section, we do. Right, so we have the time last edited, and then after that, there's 8 data points that define the cross section. All right, so we have the station and elevation. We have station number 2 and elevation number 2. So those numbers right here of 150.3 and 140.3 would show up in my cross section. Let me click on river station 300 and boom, 150.3, 140.3. The point I'm trying to make here is all the numbers that you're seeing here in this interface that define the cross section should also be something you can find in this block of code. And further down here, we have the expansion and contraction coefficients of 0.3 and 0.1. So if we go back to RAS, here's the 0.1, here's the 0.3. Right, so the same could be true for the flow data. Let's go ahead and take a quick peek at our flow file. We go back here, let's do a right click, open in Notepad++. Boom, here is the flow data. I've got 3 different profiles, PF1, PF2, and PF3, with flow rates of 100, 200, and 300 CFS. There's a little bit more information in the geometric data file right now that G01. So let's go ahead and stick with this file for our example. In addition to commas like we see right here, sometimes the number of spaces is also used as a delimiter. So for instance, right here, when we have a river reach, we have an equal sign and then we have a value. That would tell us the number of XY points defining that river reach. So instead of commas, what you're seeing is just a giant block of text. However, it's programmed into Excel or the HEC-RAS geometry file that there's going to be exactly 8 or 16 characters that are dedicated to each data point. So this right here is 16 characters that are selected. I'm not going to count them out. There's 16 right there. And that just means this right here is another 16 characters. And then this right here is another 16 characters. So it knows this is the X value, the Y value for the first point, the X value, the Y value for the second point. So sometimes if you're reading or writing data to these input files, you need to be mindful about how the value is delimited. Typically commas, like you're seeing up here in viewing rectangle, but in the case of the reach coordinates, it is a character number, which is 16. Next, what I want to do is manually make a change to the geometric data file and observe that when we open up HEC-RAS, that change has been updated and vice versa. So we could do it either way. First, let's go ahead and start by making a change in HEC-RAS in the graphical user interface, saving it, and then reopening up this geometry file. And I propose we go ahead and experiment with this expansion contraction coefficient at River Station 300. So there's also a cross section down here, which is the one at River Station 0 with 0 downstream distance with some similar numbers. It also has its own expansion contraction coefficient values. But I'm not going to be touching these. I'm only going to be making edits to the expansion and contraction coefficient values at River Station 300. Okay, so I'm going to go ahead and close this file, go back to my HEC-RAS, open up the cross-section data editor. Instead of 0.1 and 0.3, let's go ahead and change it to 0.2 and 0.4. And then I'm going to click on Apply Data. I'm also going to close this. I'm going to go File, Save the Geometry Data. Now we're ready to open up that project.g01. Looks like there's a backup file there. And then open up file in a text editor. Boom, if we scroll down a little bit, now our coefficients have been updated in the text file itself. So now I'm going to leave the text file open. I'm going to open up HEC-RAS, at least bring it to screen, save the project, close the entire application, which includes the geometry file that was open. Let's go ahead and just continue to increase these numbers to now 0.5 and 0.3. And then I'm going to save that. Now let's open up HEC-RAS, specifically the cross-section, and see what happens. Okay, so here is the project. Here's the geometric data editor. Let's open up the cross-section, specifically cross-section 3 and point 3 and point 5. All right, so that's how to make updates using the graphical user interface and observing the change in the text file, and vice versa, making the change in the text file and seeing it reflected here in the GUI. All right, now it's time to use some VBA code to read in these values, point 3 and point 5. Keep in mind, we also have a cross-section down here at River Station 0, whose original coefficients are still intact, 0.1 and 0.3. So I propose we write a quick script to extract this coefficient of expansion and contraction for both of our cross sections and doing something very simple like just printing them to the screen. After all, this is just an introduction to the topic. All right, so I'm going to click on Microsoft Excel and then open up my developer tab, specifically Visual Basic. Let me bring this over here. I already have the code written in this module number 1, so I'm going to walk through and explain it as we go. At the very top, what we're doing is defining a subroutine called print expansion and contraction coefficients. Ultimately, what we're going to be doing is printing out a couple strings to our intermediate window. That's what this line does right here. First block of code is going to open the geometry file. So this is the file path we're defining right here, and then we open it using a file handler. Input is the keyword for opening a file. I believe that's read only. And then number 1 right here is the variable to reference that file. So we can open it up using number 1. We can loop through it using number 1 and then identify each individual line and also close using this pound number symbol, number 1. Okay. If you had multiple files open, you could just use a different number. And then in this block right here, what we're ultimately doing is looping through the text one line at a time. So that text from the line is being saved into this text line string variable. And then here we're searching through that single line and we're searching for this string of text, exp/cntr equals, because that's the text that we're searching for right here. So this string of text right here is what is saved into this text line variable. And what we want to do is parse out just the values. We don't want to see the key and we don't want to see the equal sign. We just want to see that 0.3 and 0.5. Or in the case of River Station 0, it'd be 0.1 and 0.3. Right? So we're finding the position of the equal sign, and then we are defining the actual text to print to the screen. This is a Excel function right here, which will return the text line string starting at the position of the equal sign minus +1. So we're not going to include the equal sign. Lastly, this line right here will print that value of the contraction expansion coefficients to our intermediate window, which we can open up by going View and Intermediate Window or Control G. And finally, we're going to close the geometry file. All right, so let's go ahead and see if this works. The habit, I just going to go ahead and click on Save and then Run and Run Subroutine. All right, very cool. So right here is the cross-section River Station 300. This is for cross-section River Station 0. We have our contraction and expansion coefficients listed out here, comma separated, because that's what they are right here. 0.5, comma 0.3, and then in the next cross section down is 0.3, comma 0.1. And all right, well, I hope that was helpful. This was a lesson in the HEC RAS controller. This is an introduction on reading input data files, and we did a quick example here using this geometry file.